Okay, I completed part A and B early on for the critical path analysis question. Part C asks to state the critical activities. So if we look at this one here, the critical activities are ones that has no float. Basically, when a worker is working on a project, he has to start straight away on the next part. Otherwise, because there's no float, there'll be a delay in the completion of the whole thing, which we don't want. So if we'll have a look through these, we've got here 0, 0, and add 4 is 4, 4. So this one's correct. So that's a critical one. So we've got A, which I'll just put on this one. Put them here. Put it on here. So we've got critical activities at A. And from there, 4 add 7 is 11. So we've got 4 and 4, add 7 is 11, 11. So that's critical. So that's C. From here, we've got 11, add 10 is 21. You can see the match on both the boxes here. So 11, add 10 is 21 here. So J is critical. From here, 21. 21 add 9 is 30. So we've got both boxes 21. Add 9 makes 30. Both boxes 30. So that's critical, which is M. That's that part done. Now part E, let's have a look and see what part E says. Part E says, part D first. Calculate the maximum number of days by which activity G could be delayed without affecting the shortest possible completion time of the project. You must make the numbers used in your calculation clear. So that's just looking for the float, as in part A. So let's go back to D. And I need this one here. Part D here. Let's see, activity G. So this is activity G here. So as we said before, the float is late event time minus activity time minus early event time. So it's 21 minus 3 minus 11, which is 21 minus 14, which is 7 days. 7 days float. So that means you can actually wait 7 days before you can start the other event, the other activity, So you don't have to wait that far, but if there's a problem somewhere, you can wait that length of time. Okay, let's look back at part E. Part E says, calculate the lower bound for the number of workers needed to complete the project in the minimum time. You must show your working. So the lower bound, what we do here is we add up all of the activities, the times, all the way through, and I think it's a good idea to do it in alphabetical order. You can see it goes up to M, so what I'm going to do is just put them like this. A, B, C, D, E, F, G, H, I, J, K, L, M. Right, let's have a look at the activity. So we've got A is 4, add B, which is 5, plus C, which is 7, plus D, which is 9, plus E, which is 6, plus F, which is 2, plus G, 3, plus H, 3, plus I, where's I? 4, plus J, which is 10, plus K, which is 5, plus L, which is 2, plus M, which is 9. And we add those up, and we get, let's see, that's 69 there, 69. And what we do to get the lower bound is divide that by the length here of the critical path. You can see 30 there, so divided by that, because it takes 30 days for the workers to do them. So what you do is this, if I go back to the question and show you, calculate the lower bound for the number of workers that's needed. So if you did them in 30 days, if it could fit in, that would be 1 worker. Okay, that's the lower bound. It doesn't have to take that long. Usually it takes longer, but that's giving you a guide for the lower bound. So we've got 69 divided by 30, which is, let's see, 69 divided by 30, it was 2.3. So we've got 2.3. So that means 3 workers needed. That's the lower bound. LB equals that. Okay, and that's it for part C, D and E.